Alright, so we're first going to look at the MCAT prep question that was in the general problem set. And the question involves body mass index. The question says the body mass index, BMI, is a measure of relative size commonly used to assess how much one's body weight differs from what is a healthy or desirable. BMI equals the mass divided by the height squared in SI units. Now, in my version of the question, it's asking what is BMI of a 75-inch tall man with a weight of 180 pounds. Because Mastering Physics randomizes the numbers, you might have a different height or weight to the person. But what we want to do here is we want to take this equation, BMI equals mass divided by height squared, and we want to use the measure that we were given to calculate BMI. So we have to convert our units first. So I'm going to scroll this up here so we get what we want here. So I'm going to label these as some variables. So I'm going to rewrite BMI equation using some variables. So I'm going to use W for weight and H for height. And then we'll take the units we're given here. H equals 75 inches. And one thing you should note when you're looking at problems like this is saying 75.0. So it's telling us there's three significant figures here, because that 0.0 conveys information. And the weight equals 180 pounds. Now, 180 pounds is ambiguous. It can be taken as 2 sig figs because we're not notating that the 0 is needed, or it could be 3 sig figs. Due to the other measure in this problem, I'm going to make the assumption that it's 3 significant figures. This is why in our labs we'll use error to specify what is significant and how much error there is in our measurement. And you'll see this ambiguity with any number that ends with a 0 before the decimal place, that unless it doesn't specifically notate it, we're not 100% sure what the sig figs are. Normally you put a bar over it like this to suggest that it has the third significant figure. If we look at the problem directly, it's looking for answers with 3 significant figures. But I'm mentioning this because when you're reading different problem sets, you have to be aware that sig figs do have this problem of ambiguity in their notation. So we want to convert to SI units. So the SI unit for length is going to be the meter. So I need to convert my H to meters. So I'm going to start with that. And so I'm going to build conversion fractions like we've been doing, or conversion factors, by using the equations that we know. Now, I start with the definition that 1 inch is 2.54 centimeters. So my first fraction, I need inches on the bottom, so 1 inch. And on the top, I need 2.54 centimeters. 2.54 centimeters. So that's our first factor that we're going to multiply our measure for. The inches will cancel. I'll do that in orange here. And so now we're in centimeters. But what we want when we're said and done is meters. So we have to do one more factor, which is 1 meter is 100 centimeters. Again, the centimeters will cancel, and I'm left with something The only unit I have left is meters, which is what I want. That's the SI unit for length. So I'll pull up the calculator here so you can see this entry. Let me get my calculator open. And we can take these operations. Multiplications and divisions are of equal order of operations. And so we can move from left to right. So I have 75 times 2.54 divided by 100. And that's 1.905 meters. Now, because this isn't the answer final for the problem, we're going to keep an extra significant figure to avoid errors with rounding. So let me get 1.095 here. 1.905 meters. So we want 3 sig figs in our final answer, but this isn't what's going into our equation. So you keep the extra digit to avoid rounding errors. So normally when you're moving things from calculator to from different parts of the equation, at the most you'll need one more sig fig than what your equation is telling you. I'll sometimes keep 5 sig figs for 3, just because it comes out of the calculator larger. But for this problem we can keep 4 sig figs, remembering our final answer will be in 3. So that's the height. We're going to do the same thing for the weight here. So W equals 180 pounds. And we're going to build our conversion factor. Now if you look on the sheet, it says 1 kilogram has a weight of 2.2 pounds, where G equals 9.8 meters per second squared. One of the things that is happening here is English units measure weight in pounds. SI units don't deal with weight as a specific thing. Weight is how much mass is affected, or a force affected by mass. And so we could measure weight in newtons, but more often than not, what you're actually talking about in English units when you talk about weight is you're measuring its mass. You're assuming everything's near the surface of the Earth, and that G is that 9.80 meters per second squared. And that's what the conversion sheet is asking here. So we're going to use that 1 kilogram equals 2.20 pounds. When we get into Newton's laws, we're going to redefine weight a bit. And so this is something we have to keep in mind when we talk about the concept of weight. It's from the idea of English units, we use pounds. In SI units, we use newtons. But this question is actually asking about mass. And it's kind of the ignorance of older measurements where this comes from. So we're going to use this 1 kilogram, goes up top, because that's what we want. And on the bottom, we're going to have 2.2 pounds, 2.20 pounds. And this is building our conversion unit from the equation. And again, I'll pull out the calculator here. And we'll get our conversion. So 180 divided by 2.20 equals 81 repeating fraction. And so we're going to keep 4 significant figures to avoid rounding errors, so 81.82. 81.82. 81.82, and our unit, because the pounds canceled, is going to be kilograms. So 81.82 kilograms. So I now have everything in SI units, which is what our equation was asking for. So we look back up here, BMI equals weight divided by height squared. So BMI equals 81.82 kilograms divided by 1.905 meters squared. Again, we'll grab the calculator out and enter that in. So 81.82 divided by parentheses 1.905 squared equals 22.54. Well, I want 3 sig figs, so 1, 2, 3, 22.5. And so this is a BMI of 22.5.